Ladies and gentlemen, we are here with fourth period honors geometry for a live studio audience version of 11.7. Woo! All right, let's hop to it. All right, we got a wonderful problem here. Given two equilateral triangles with sides 2 and 6, we got to find a few ratios of the sides, the perimeters, and the areas. We're going to give our studio here a couple minutes to work these, and we'll be back with an explanation. All righty, the class has now worked this incredibly fun problem. So, ratio of the smaller to the larger sides. What do we got? Crickets. Vivek!
Huh?
Ratio of the smaller to the larger sides.
1 to 3.
Yeah, so if we had 2 to 6, and we simplified it, that's a nice 6 right there, it would become 1 to 3, which you can write as a fraction or as with a colon between it or whatever. All right, the ratio of the perimeter of the smaller to the larger. What do we got for the perimeter of each one? First off, Aiden, what'd you get for the perimeter of each?
For the equilateral triangle 6, I got 18 and then 6.
6 and 18, right? For my two perimeters, which simplifies down to? 1 to 3. Ooh. How about the areas? What do we get for the area of each?
For the area of the two-sided triangle, we got root 3.
We got root 3 for the one with side 2.
Yeah.
And then how about the?
The one with side 6 is 9 root 3.
9 root 3. And you could do that by cutting into 30, 60, 90 triangles, or you could even use the side squared root 3 over 4 formula to do that. All right. So if we simplify this, these guys would cancel, and what am I left with for my ratio?
1 to 9.
1 to 9. Oh my goodness. What happened here? Could we generalize what happened here? Aiden.
1/3 times 1/3.
Okay. 1/3 times 1/3. So in other words, if you're multiplying something by itself, squared. All right. If we're talking about a length, it's just the normal lengths when you're doing the ratio. But if you're talking about area, you need to square that, and we're going to write that down next. All right, so something important to jot down in your lovely notebooks would be the perimeters, the ratio of the two perimeters are equal to the ratio of the sides. We're talking about if you have similar figures. Okay, so if we have similar triangles, equilateral triangles are similar triangles. They are the same shape, same angles, but the sides are just proportional. So the sides are an equivalent ratio to the perimeters. But the areas, you'd have to take your sides and square them. And the same thing would happen with a quadrilateral. Let's say we had a square with a side length of 2 and 2. My area would be 4. But let's say I take another one where the sides are, let's say, triple that. So it'd be, or actually, let's do different numbers. Let's go quadruple. So 8 and 8. Well, that would be 64. Well, 4 times what gives me 64? 16. I quadrupled, meaning I multiplied the sides by 4. But since I'm dealing with area, that's squared, which is 16. So it's 16 times the area. All right, whatever I'm doing to the sides, I need to then square that if I'm going to be comparing those areas. Any questions?
No.
No. All right, moving on. This next one here, we want to find the ratio of the areas of two equilateral triangles with sides 6 and 8. Very similar to the one we just did.
Yeah.
Alrighty, ladies and gentlemen. So many of us have just discovered that we don't actually have to find the areas to answer this question. We can use what we just wrote down on the previous slide. So if I want to know my area 1 to area 2, we'll say of my triangles, which will be my 6 and 8 side triangles, what can I do with those sides since they are similar figures? Ava.
You can set them in a ratio, so you square the one and then you square the other.
Perfect. I can do my sides squared over my side squared, which would be what, 36 over 64. What does that simplify down to? 80. 9 over 16. Boom. As we know, ratios can, if they can be, they should be simplified down, reduced. That's right. Any questions, children? Lovely. Wait, were we going to do an applause?
Yeah, I think it works.
Applause. All right. Applause sign went up. All righty, for this problem here, if the ratio of the areas of two similar parallelograms is 49 to 121, find the ratio of their bases. Now, these are similar parallelograms. Remember, what we have only works with similar figures. So what can we do with this ratio of the areas, which is 49 to 121? If we know that it's our side squared over our side squared is what gives us those area ratios. Mr. Vivek.
Square root of the ratio.
Square root. So what do we get when we square root both? Aiden.
711.
Wow.
Ah, ha, 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 ha. Oh, I thought we were going to do a laugh track. All right, applause instead. Woo! Very good. 7 to 11. All right, this next one here, we got to find the ratio of the area of the larger triangle to the smaller. So make sure you do set up your ratios in the proper order based on the wording of the problem. So it looks like I got some 30, 60, 90 triangles. So would that mean that my triangles are similar since their angles are congruent? Yes, it would. It looks like the one on the right-hand side is just a little turnt. It's rotated in a different direction, but that's cool. We can handle it. We can handle it. All right, so for the bigger one, which side is my 10? My x root 3, or my 2x? 2x. Mr. Odachenko has now entered the room during the live studio audience recording of 11.7. And Mr. Thornley, my goodness, celebrity appearances.
So,
All right. So yes, the 10 is my 2x. So what's half of 10?
I'd like to thank you all for taking the time to share in this moment with me.
Indeed.
I feel privileged to know that half of 10 is 5.
would you like some M&Ms?
We're gonna pause here momentarily.
No.
Oh no, we're leaving it going.
Those of you watching the video, would you like some M&Ms?
Hey, futuristic M&Ms that can be delivered through my Gen 3 iPad. Alrighty, so we got 5 and 5 root 3. Now, which is my 4 side? What do I do with that? That is my x, so this would be 8 and 4 root 3. Now, did I really need to find all my sides to do this?
This is great multitasking.
This is awesome.
This is great.
I love this. Yes, Aiden.
All you need to do is multiply 5 and 4 by 2 and then do the...
Not by 2. What do we do with my 5 and my 4? Square them. There we go. So I could find my areas and then get the ratio. Or I could take my new fancy-dancy dealio. I'm going to do that in red. And I can do the 5 squared compared to the 4 squared and get 25 over 16. And that would do it. If you found the areas, you would still get the same answer. Pretty dope. Questions on that one? Man.
When you do the base times height, not this thing, I got 8 over 12.
That seems
I
strange.
got it too, though.
I have a question. If you double each of those, 16 and 25, right? But make sure it's the larger to the smaller. So you'd have to flip what you have.
So it's the same thing.
You got it. All righty, wonderful. Moving on. All right, we got ourselves a doozy of a problem here. We got to find the ratio of area 1 to area 2. And if you look at your congruent marks, we can see that both this segment here and this segment here, these guys are congruent to each other, meaning this is a median of the larger triangle that houses these two triangles. All right. So there were some rumblings in the crowd that it was a 1-to-1 ratio, but let's see if we can figure out why. If my base of this one is x, what's my base of the other one? X as well, right? So my bases are the same. Now my next question to you is, well, what's the height? If I look at what my height is, which is basically this right here, that is my height. My height is the same for either one. All right, so if my height is the same and my base is the same, what's going to happen with my area? It's the same. So indeed it is a 1-to-1 ratio. And we would leave it like that, not just write the number 1. That way it shows that it is a comparison, okay? So a median of a triangle divides the triangle into what? 2 equal areas. They're not congruent triangles, but we'll say 2 equal areas. Aye. Only a couple more left. Actually, one more problem left. One more problem. One more. All right, here we got another final problem. Find the ratio of the area of the shaded triangle to that of the whole triangle. So we're talking about the entire triangle, DAC. All right? Well, I've got my bases, it looks like, of the triangles, but I don't have any information about my height. Nor do I know if these triangles are similar. So I can't just use my side squared over side squared for something like this because it doesn't say that they're similar, nor are there any congruent marks to indicate that they are similar. So where can I go from here? Could I write out my area of the shaded triangle at this point in time? I see some nods. Anyone want to tell me what that would look like? Crickets. This is unfortunate, but it happens in a live studio audience setting. All right. What? A hint. Well, my base of this triangle is 4, right? And I know my area equals 1/2 base times height. So I know my base is 4, right? So 1/2 times 4. Do I know my height? Let's just pop an H. Pop an H on there. All right? Now, my larger triangle, which is this guy, what's my base of that one? 9. Do I know my height? No. Is it the same as the shaded one? Yes. My height is, in fact, that for both of them. So the height is the exact same H. I'm going to create a ratio. Now it's 1/2 times my base of 9, as you guys said, times my height. Well, what's going to happen here? Gone, 4 to 9. Whoa! Again, this is not a squared side type of problem because these are not similar figures. So you have to be careful with that. It has to be similar figures in order to apply the side squared over side squared is equal to the area over the area. All right? Any cues, ladies and gentlemen? Woo! Keep it going, keep it going. Woo! All right. Quiz, not tomorrow. Ignore these as these things change. All right, but the H-dubs is right up here for you children. I just had a voice crack at the very end of the video, and I will leave it in.
Yay!
Yay! All right, America, freedom, rock and roll, and Costco memberships.